Alzheimer's disease is incredibly debilitating and devastating, and it's one of the leading mortality causes in the elderly. However, there's currently no cure, and existing treatments can only relieve symptoms. So the health of the patients gradually deteriorate and becomes completely dependent on their caregivers. It has been estimated that there are currently about 35 million Alzheimer's disease patients worldwide. These numbers will continue to grow due to the aging populations, and this imposes, so finding a cure for Alzheimer's disease is a global priority. Alzheimer's disease is a degenerative brain disease that mainly affects individuals of age over 65. Patients suffer from memory loss, impaired reasoning and judgment, and reduced locomotion abilities. Because of the progressive nature of the disease, symptoms worsen over time. A major obstacle to developing effective treatment is that the cause of Alzheimer's disease is not known. Also, research has shown that patients are afflicted with the disease long before symptoms are visible. It is therefore urgently required to develop therapeutic interventions that are effective in the early stages of the disease. HKUST is at the forefront of Alzheimer's disease research. Recently, my research team has made a number of exciting and significant discoveries. Just to name one, we discovered that the protein FA4 has a critical link to Alzheimer's disease pathology, and our findings really open up a new research direction for identifying therapies to treat the disease. In a healthy brain, FA4 regulates the communication between brain cells and is critical for learning and memory function. But we found that in Alzheimer's brain, FA4 is abnormally activated. So this overactivation actually impairs the communication between brain cells, resulting in a cognitive decline. So we believe that targeting FA4 is a good strategy to prevent or slow down the progression of the disease. And indeed, our findings shows that if we interfere with the activity of FA4, it can improve the communication between brain cells using Alzheimer's disease mouse models. Excited by our findings, we explore the potential of blocking the FA4 signaling pathway as a therapeutic intervention. We set out to look for small molecules that act as FA4 inhibitors. So in collaboration with my chemistry colleagues, we used a computer simulation analysis to screen for FA4 inhibitors from a traditional Chinese medicine database. And we successfully identified rincophyllin as a FA4 inhibitor. Rincophyllin is a naturally occurring compound in the traditional Chinese medicine gotung. When we fed rincophyllin to Alzheimer's disease transgenic mice, we found that this compound can block the overactivation of FA4. It can also improve the communication between brain cells and memory function. Importantly, it can reduce amyloid plaques, which is a pathological hallmark for Alzheimer's disease. So in my opinion, I believe our findings are extremely exciting and groundbreaking, as we demonstrate for the first time that FA4 has an important role in Alzheimer's disease pathology and has immense value as a therapeutic target for drug development.